Ladies and gentlemen, in today's video, I'm going to walk through another try hack me room. It's going to be a simple exercise. We are going to learn simple reverse engineering today. And they gave a binary file. All we need is to reverse that binary and spot the flag. Without wasting the time, let's begin. So now we are in the challenge. Actually, the challenge name is 0x41haz. The name might look weird if you are a typical user, but it's a hexadecimal representation. And let's see what it actually means. 0x41, I'm converting from hex, and it is nothing but the character A. And let's see its description. It's a simple reversing challenge, and I have not given much information on this task, but let's read what we have given. Find the password. In this challenge, you are asked to solve a simple reversing solution. Download and analyze the binary to discover the password. And we have to download this task file. So this is where the binary located. And look at the hint here. There may be anti-reversing measures in place. So this is very important. We need to keep this in mind. And apart from that, nothing we have. Let's see what is the hint here. So they just gave the flag format as a hint, and we need to submit the password here. So we need to find the password and we need to put it in the flag format and we need to submit. So that is what the task we are having now. So let's begin. I already created a folder called 0x41haz under the tryhackme file, tryhackme folder, and I also downloaded the binary here. So this is the binary we are currently having. So whenever you are getting a file, you have no idea what sort of file it is. A simple utility is file, simple and powerful utility offered in Linux. So I'm just using this utility to find the file type. So once I try to find the file type, I can see some weird information here. So let's see what type of file it is. It is ELF, executable and linkable format, and 64-bit architecture. That is what it is showing, and most significant bit, which means big Endian, I believe. And apart from this info, I'm seeing unknown architecture and SYS2. So it is saying the architecture is unknown. So what does it mean? I'll explain. But before that, since it is a binary file, we can either use a disassembler or debugger to see the disassembled form of binary. So let's try to run Ghidra. So I'm just trying to run Ghidra, and let me load the binary into Ghidra and see what happens. I already created a project. I'm simply going to import the specific executable file. Yeah, this is the file. If you see, it is finding this binary as ELF binary, but the language is not given. Destination folder is present here, but program name is given here. However, I couldn't click OK and proceed further. If I click this language button, it lists the processors, the list of processors. And when I try to load this binary, this Ghidra application couldn't find the type of architecture and the type of linking, whether it is dynamic linking or static linking. So that is why we couldn't load this into Ghidra. So because they already mentioned in the exercise that there might be some anti-reversing measures in place. So it looks like a binary which is having the anti-reversing feature. So we need to break that. We need to correct that binary in order to load this binary into Ghidra. But before that, let me confirm it with another application called Radar2, R2. We can simply call it's a command line utility. I can load this binary within this R2 application. So once I load this, I can see its command line. I need to click A to choose the analysis mode, and after this, I need to choose the function. Now the binary has been loaded. Now I need to choose the function. In order to choose the function, I need to press the letter S for operation seeking, and main. I need to choose the main function, and it is done. Once I clicked this, I can see cannot seek the unknown address of main. So I couldn't seek the main function here. Now let me enter the another command, printing disassembled function. So Now I gave the command to choose the main function, but I couldn't choose the main function here. However, I am choosing the option of printing the disassembled function. So that is stands for PDF. And once I give that command, I can see cannot find function at this specific address. So which means even when I try to load this binary into R2 application, I couldn't load this properly. So this is what called anti-reversing feature, and we need to correct that. We need to correct this corrupted binary in order to load it into disassemblers or debuggers. So let's see what we can do. I have no idea what needs to be done, but however, I'm just selecting this specific line and I'm going to Google to get further idea. So I'm just giving this specific string that I got from this file utility result, and I am just opening the first blog given here in this Google. So let's see what we are having here. The blog has been created for completing the requirements of Security Tube Linux Assembly Expert certification. All right. Obfuscated shellcode. First is the shellcode that use some obfuscation techniques. This is not the relevant one that we are looking for. Let's see the unique trick. Second is the technique I found myself as I was working on Linux ELF format. Yes, we are working on Linux ELF format. I noticed that it is possible to change some bytes in the ELF file header without altering the normal execution of the program. So here the point is very, very important. For instance, you can persuade your executable is 32 bits even if it is really a 64-bit one. You can also indicate your binary is made for big Indian platform even if it is reality. I mean, in reality, even if it is not true. This technique may be useful against reverse engineering. Yeah, seems to be some pertaining info. In order to alterate the header, you can use any hexadecimal editor like hexcurse. The fifth byte defines the format, whether it is 32-bit or 64-bit. If it is 32-bit, then it has to be 1. If it is 64-bit, then it has to be 2. They are defining the, I mean, it is defined by the fifth byte of the binary. And when we go to the sixth byte of the binary, it defines the endianness. Whether it is LSB or MSB, has to be 1. It must be 1. So let me zoom this page a little bit. If you see this specific binary, this is the byte. I mean, this is where the binary byte begins. And if you count fourth, fifth binary, the fifth byte is 02, which means it is 64-bit binary. And if you see the sixth byte here, it is 01, which means it can be either LSB or MSB. And alterate the ELF header, save and run your shell code, and you will see that it is running like charm. If I scroll down further, I can see the same sort of error message that I got earlier. If I scroll a little bit further, yeah, I think we need to modify this either this fifth byte or sixth byte. First of all, let me read this binary in the hex editor. I'm using the application called hexedit, and I'm just bringing that binary within the hex editor. So this is where the binary begins. The fifth byte is 02 and the sixth byte is 02. Here you can see both fifth and sixth byte are 02, but what we have to witness here, sixth byte must be either LSB or MSB. It must be 1, but here we can see it is 2. So why don't we modify this sixth byte? It has to be 1, the sixth byte. Now I modified it and I am pressing Control W, I believe. I modified the sixth byte. Now I am pressing Control X to save and exit. Now I did that modification. Let me use the file utility once again to check the type of binary. Now I can see. Now I can witness the binary properly. It is showing the linking type and also the architecture along with whether it is stripped or unstripped, and also the build ID details. Now I corrected this binary. Before, you need to understand one more thing. You can persuade your once again here. Yeah, I noticed that it is possible to change some bytes in the ELF file header without altering the normal execution of the program. So even if you are having the file that we directly downloaded here, the corrupted binary, it won't affect the execution. You can able to execute that binary without any issue. But however, you cannot reverse or you cannot do some disassembly operation on that binary. So this is the binary that I recently downloaded. Let me copy this binary and I'm trying to execute this binary. This is just a showcase. The corrupted binary can be executed without any problem. So this is the binary. Let me change its privilege. Now I changed its privilege. If I try to execute this binary, I'm actually I asked it to give an input. Hey, can you crack me? It is just a simple binary. Tell me the password. I don't know the password. I am just telling hello YouTube and enter nope. This giving the message nope and it is exiting that execution. And it looks like a simple binary. What we have to do, all we need to find is the password to successfully execute this binary. But now I successfully showcased that irrespective of the corrupted binary or not, it won't it won't affect the execution. Now let me take this binary. The binary after we did the correction, I'm just modifying the privilege here. Let me remove this binary. It's no longer required. Oh, sorry. Yeah. Now I'm going to load this binary in Ghidra. So let me load this binary in Ghidra first. It says I'm already running a project. Yeah, I'm already running. So let me close this project. All right. Now I'm trying to import this file and this is the binary. Now I can see it is detecting its language, what sort of compiler it is, and the architecture, and also the destination folder project name. Now this button is enabled. I can click OK and load this binary into Ghidra. Now I will be able to reverse this binary properly. I can also see the details of this binary, an overview. Let me open the code browser in Ghidra. Yes, I would like to analyze it again. Okay, now I got this window. Here is the disassembled view of the specific binary. However, I'm not sure where should I look. In this case, I'm just opening the specific functions tab and I'm just trying to read the function one by one. You can also do one thing here, one more thing. You are aware this binary is having a string. No, I cannot execute this binary because I already loaded it in Ghidra. Not a problem. Uh, I was able to see the string related to crack password like that. So what you can do, either you can try with that specific string and you can directly navigate to that specific place in this assembly code. Otherwise, you can check this function one by one to spot the specific main function. Here I don't see any function called main function. However, if I scroll, I mean, if I navigate the function one by one, here I can see the specific string. You can see this window, right? This window denotes the decompile window. Here you can see the decompiled code view of the specific disassembled part. Uh, yeah, here is the function. I can rename this function as main. So this is my main function, and if I see the details here, here they are defining some variable, but they are not defining its type. That is why it is undefined. And if I see further, I can witness the values assigned to the specific binaries. And these values looks like some hexadecimal values. And you can see the hexadecimal values here. And I'm looking further, it is simply printing the specific string, hey, can you crack me? And the message, it is just a simple binary and tell me the password. It is asking the password and it is getting the password through this get function. Let me move to the specific function once again. Here the function is gets, actually it is getting the local underscore 48. That is the specific array. If I see this local underscore 48 variable, it is a character array of size 42, and it is just trying to get the output. I mean, trying to get the input from the user with the gets function, and it is doing some comparison here. I believe it is just measuring the string length of the specific input and putting it in the yes var one, and after that it is just denoting the local underscore 10 variable. Actually, it is integer variable. So they are just putting it again within this specific local underscore 10 variable. And the next code block, if you see, it's a if condition. Actually, the condition is if the specific variable is not equal to 0 into d, then it is correct. I don't think so. It is giving an error, which means, I mean, the wrong password you enter. So that is the error. And if I'm moving further, I can see local underscore c equal to 0. They are defining value as 0. And while it is true, it is doing another comparison, 0 into c hexadecimal letter less than local underscore c, and puts well done and returns 0, which it looks like the successful entry of the password. When you enter the successful password, you will get the message like well done. And let's see what is the condition to be satisfied in order to get this well done message. And what it is actually doing here, let's try to understand. I can see the variable local underscore le is being called. Local underscore le is nothing but this hexadecimal string, and I can see they are denoting the local underscore le variable, and we already know its value is given here. It's a hexadecimal string. I can able to convert this hexadecimal string to ASCII. But however, I can see further, it is simply doing some concatenation with local underscore c. Uh, however, I can see the other variables being called local underscore 48 and local underscore c once again, and local underscore c plus 1. So I literally have no idea what is exactly happening here. It is quite confusing. However, I can see it is referring this specific variable. What I can do, I can try to decode this specific hexadecimal string, hexadecimal value, and along with this hexadecimal values as well. So let's see what we are getting once we decoded this. And yeah, I am using the utility cyberchef. So let's use the utility cyberchef here, and it is from hex, right? Yeah, when I decode it from the hex, I can see the value as fg $52 at 2. So let me paste it somewhere. I'm pasting it here, and let me decode the second hex value as well. 4C. What is 4C? 4C denotes the letter capital L. All right. So looks like this is the string, but let me try to concatenate this string, and it looks like a password. So why don't we concatenate these strings and try concatenating the string. So let me copy this binary because I cannot disturb this binary as it is loaded to Ghidra now. I'm just taking copy of this binary and giving the name I wish. Copied binary. So that is the name I'm giving. All right. Now let me try to execute this copied binary. It is asking me the password. I'm just pasting the password I got, but it is the wrong password. I'll tell you the reason. Uh, Earlier, if you remember, we have witnessed MSB here. When we are checking with the file utility, the corrupted binary, we found MSB here, which means big endian. But after we corrected this binary, we got LSB, which means little endian. So there is a difference between big endian and little endian. You have to reverse this specific string in order to convert it into little endian. So that is what we have to do. We have to reverse this specific string, this specific string, and this specific string. Then we need to concatenate. So let's try to do that. It is little endian now, but earlier, before I was correcting that binary, it was MSB, most significant bit. So in order to give password for this specific LSB binary, we need to reverse that string. We need to reverse that concatenated string. Before concatenating. So what we can do, I am using the utility R2 against the binary, and I am using the letter AAA once again, and I am mentioning the specific main function. I'm seeking the main function and specifying the printing disassemble function. And when I give that, I can see it only displays the disassembled view of its main function. And its main function is nothing but the same function that we witnessed on Ghidra. This is the main function we are talking about. And if I see the value here, I can clearly witness the reversed value. It begins with 2 at the rate $25 GF. But here, when we converted directly from hexadecimal, we found FG$52 because it is the big endian format. But here in this Redare 2, it is directly showing the proper format. Now we can simply do one thing. We can concatenate the string that we have got, and we can try it as a password. So now we got the password. So let's try that password. Now I cannot execute this binary, hence I am choosing the copied binary. Giving the password. Yeah, now we got it properly. So this is the specific password that we wanted. We are not getting any flag here, but the password itself the flag. So let's try to put it in the flag format, THM, within the curly braces, submitting it. Yeah, with this, we have successfully finished this exercise. And yeah, this is what exactly I wanted to showcase. We really experienced a new thing today. We have learned a simple reverse engineering stuff. I haven't done this before. This is the first reverse engineering video of mine. Hope you really enjoyed it. If you really did, hit the like button, consider subscribing my channel. If you have any other opinion, put it in the comment section, and you can also share this video among your friends. I'll catch you next time with another exciting video. Until then, I'm signing off. Cheers and love you guys.